this next series of videos, we're going to be starting chapter 5, which is all about the structures and shapes of molecules. To start off, at the beginning, the next series of videos are going to be about drawing something called Lewis structures, also called Lewis dot structures. So the first few examples that I've chosen for us are very simple, and then we will move into things that are a little bit more complex. So the first compound that I've chosen for us is chlorine 2Cl2. In order to go about drawing these Lewis dot structures, we have to first determine something called valence electrons for each element that is in our compound. So we have chlorine, so this one's pretty easy because it's just chlorine. So the way that we determine valence electrons is from our periodic table. So the number of valence electrons is actually equal to the column that the element falls in, skipping the transition metals. So the transition metals are typically very weird. There are many exceptions to the rules here. I'm going to skip the exceptions. We're just going to go over the basics. So everything in column 1 has 1 valence electron. Column 2 is 2 valence electrons. Skip the transition metals. Then over here with boron, this is 3 valence electrons. Column with carbon is 4 valence electrons, 5 valence electrons, 6, 7, and 8. So referring back to my example molecule, the only element I have present is chlorine. So I'll count over 1, 2, skip, 3, 4, 5, 6, 7. So this column here, the halogens, is where I find chlorine in my periodic table. So chlorine itself has 7 valence electrons. So chlorine has 7. The next thing that I'm going to do here is draw chlorine with these valence electrons depicted around it. And the way that I do that is just with the chlorine symbol itself. That's a little small. Let me write it a little bit bigger for you. There we go. Okay, so chlorine with 7 valence electrons around it, and I just represent these electrons with dots. So I need 7 dots around my chlorine. So I'll do 1, 2, 3, 4, 5, 6, and 7. So this is chlorine with 7 valence electrons around it. But my molecule has 2 chlorines in it. So I need to draw a second chlorine that also has 7 valence electrons around it. Okay, so now I have 2 chlorine atoms with 7 valence electrons around them. The next step is when we make molecules, we typically don't have elements that are just floating around in space. They like to form what we call bonds. So if you recall from chapter 4, we talked about the 2 types of bonds, ionic and covalent. So looking at chlorine here, chlorine is one of the halogens. So it's a non-metal. So I know that this is a covalent molecule. And because it's covalent, I know that the electrons in whatever bonds are formed have to be shared. So I will abbreviate electrons as E- here. So the way that we show a sharing of electrons, so each of our elements here has 7. So they're kind of paired up around the sides, 2, 2, and 2, but then there's this lonely electron over here on the side. This lonely electron is the one that's going to try to do the sharing. It doesn't really matter which electron itself is the lonely electron. It's just the way that I have it drawn. The way that I show that they're being shared is by drawing a double-headed arrow between the 2 to show that these 2 electrons will come together to form a bond. And when I am ready to draw my Lewis structure with the bond itself, I will draw the chlorines attached by a bond. So this is just a straight line drawn across. This represents the bond. So each bond has 2 electrons being shared. So each bond represents 2 electrons here. But when I finish up my Lewis structure here, I'm not quite done yet because there are all these other 6 electrons around each of the chlorines that also need to still be represented. So the Lewis dot structure must represent all of the valence electrons in the structure. So this bond here only represents the 2 electrons that I showed were being shared here. So the others that were all paired up around the chlorine still have to be drawn in the Lewis structure. So I'll go ahead and do that. And now I have 1 bond, and each chlorine has all of its valence electrons around it. The last thing that I want to do is I want to make sure that this Lewis structure makes sense. So sometimes when we get into the more difficult examples, you'll find that there's a couple of ways and they look correct, but they don't necessarily make sense. We have to check something called the octet rule. So the octet rule is also called the rule of 8. So all elements, with the exception of hydrogen, which we'll cover in a few examples, all elements want to achieve this rule of 8. They all want to have 8 valence electrons around them. So if you recall from when we talked about forming ions, all of the elements want to be more like the noble gases. So if we determine how many valence electrons are in a noble gas, 1, 2, 3, 4, 5, 6, 7, 8. All noble gases, with the exception of helium, have 8 valence electrons around them. So all elements want to also have 8 valence electrons around them. So this is where the rule of 8 comes from. They're trying to achieve more noble gas-like conformation here. So we have to make sure that each of our elements is, I like to call it satisfied. We have to make sure that the octet rule is satisfied here. So we want to make sure that each of these chlorines has 8 electrons associated with it. And they can be associated with it in a bond or as dots surrounding the chlorine. So if we start with the one over here on the right, I can see that I have 6 dots around the chlorine. So these are 6 electrons that are not in any sort of bond. And then in the bond here, remember each bond, each line between elements represents 2 electrons shared. So even though chlorine only originally had 1 lonely electron here, it is now sharing the other electron from the other chlorine. So it does have 2 electrons in that bond. So 6 free electrons around plus 2 electrons in the bond equals 8 valence electrons floating around chlorine here. So this chlorine over here on the left-hand side is satisfied by the octet rule. We would do the same thing with our right-hand chlorine here. Make sure every single element in your structure is satisfying the octet rule. If they are all satisfied, then your Lewis structure is complete. You are done. So double check here, 6 electrons plus 2 in the bond here also equals 8. So this structure here that we have done for chlorine is complete. It is fully satisfied, so we are done.